This conference will now be recorded.
Okay, so good morning, all, and welcome back to the session. This is Mastering Big Data with Cloud. In the previous session, what we have discussed about AWS stuff, and from the AWS side, what we have seen the Athena. Okay, and from Athena, we have discussed how to do optimization on to top of Athena tables. Previously, what we have seen while creating the tables onto top of the data which is there inside the S3, uh, what we were visualizing at that moment, the table without optimization was taking too much time. If we are querying onto the table, if we are selecting one column only, then also it was taking too much time and it was scanning the all of the records from that particular table. This we have seen now, and it was taking too much time. So inside the Athena, the cost is based upon the scanned data. And if scanning is more, then definitely we need to pay more cost. In order to minimize that particular cost, what we have done the partitioning onto top of that particular data. Okay, partitioning while creation of the table, we are just mentioning a particular column based upon what we just need to do the partitioning, and once we are doing the partitioning, the data will be stored in partitions. It is going to pick the partitions from the S3, and at that moment the scanning will be less. So over here we have created the partitioning, and how this particular process was performed. So we have loaded the data in S3, and let me show you. In S3 we have loaded the data. So AWS console, and in AWS console in S3 bucket, we have loaded the data in terms of partition. And once we are creating the partitions, we know it very well. We are creating partition create the folders or directory. Yeah. So what we have done, onto the local, we applied the partitioning onto the data, onto that particular data, and those particular partitions we have moved inside the S3. Just have a look. This was the partition data. Post analytics new folder. Over here, this is nothing but the partition data. Okay, so these are the partitions data, and once it is created, so once it is loaded inside the S3, then we need to create the tables, Athena tables, onto top of this, and then we will be able to scan the data over here. So we have provided the path up to flight data new. We are not like, we have not provided the path with respect to the destination ABQ. Just have a look onto this particular query. So we have provided the path. So location S3, boost analytics, and flight data new. So whatever data is available in this particular folder, so over here in this particular folder, just have a look. Flight data new. This is the folder. In this particular folder, we are having these particular directories, you can say, or subfolders. So these are nothing but partitions with respect to the data. Okay. Now what we need to do, we just need to create a table onto top of this particular data, and then we will be able to scan it. And now we have done the partitioning, and once we are going to scan, it is going to scan one partition only. Now the main question over here, based upon what we need to do the partitioning. based upon which column we need to do the partitioning. So you just need to tell me based upon which column I just need to perform the partitioning over here. Which column I need to prefer? I have preferred the destination DEST. Why I have not picked the engine column, or why I have not picked the type column? Why I have picked the destination as a column for partitioning? And what is the significance of destination over here? Why I need to perform the partitioning based upon the destination? You just need to
Due
tell
to
me.
low cardinality,
Due to low
like
cardinality.
cardinality. Yes, yes.
Huh? That is fine. But low cardinality is there, then you are moving with partitioning. That is perfect. But why I need to choose destination column for partitioning? Or in another words, which column I need to prefer for partitioning? In this particular data, it is not like say destination is having low cardinality. Model is also having low cardinality. This type is also having low cardinality. Engine is also having low cardinality. I'm having multiple columns which are having low cardinality. Month is also having low cardinality. Like say first month, second month, third month. So is also having low cardinality. But why which column I need to prefer for the partitioning? That is the main question.
If like we need the data as per destination only. That is why we create that
Hmm.
partition by.
That's the correct answer. You just need to have an idea based upon which column you are going to perform the query, based upon which column you are performing the execution. Say I'm performing the execution in such a way like select star from the flights data where destination equal to this, where destination equal to ABC, where destination equal to uh, IND, where destination equal to say DEL, Delhi. Okay, so you just need to have an idea that my queries are based upon this particular table, and I need to scan the data based upon this particular based upon this particular column, and this column is taken into consideration multiple times. So I need to proceed for partitioning based upon this particular column only if I have performed the partitioning say based upon model. So that will not make any sense. Okay, still it will be taking too much time. Probably it will be less than the initial one, but it will be more if we have moved with partitioning based upon model and we are curing based upon destination, right? Is it fine?
But sir, we
Got
perform
it.
the partition or other action on a particular column as per customer requirement. No?
Yes, as per customer requirement, we just need to choose a column. Like this is the column. Based upon this, I just need to perform the optimization. And what optimization I'm going to perform? That is nothing but partitioning. Now you just need to check like whether onto this particular column you are having the idea that this is the column based upon what I'm going to perform the query. Now you just need to check, can I proceed for partitioning onto this particular column? What is the cardinality of this particular column? Is it low or is it high? If it is having high cardinality, then partitioning is not going to boost the performance. Then you can proceed for say bucktization and all that will provide certain uh, boost. Okay, onto the performance. You can apply compression and all. You can change the file format. So those particular things you can apply over here in order to boost the performance. Like if you are going to write it somewhere, okay, so then you can think in that particular way. Okay. Okay, is it fine?
Yeah, right, sir. Right, right.
Got it.
Okay. So this was the stuff what we have seen in our previous session. So we have created Athena table and applied the optimization onto top of that. So this was the manual stuff, and in each and every column, or in each and every moment, we just need to have an idea about like how many columns are there, what will be the data type of that particular column. We just need to decide that. That was the manual stuff. But this Athena is also providing a way in order to infer the schema automatically, and for that what we are having glue. Okay, so creation of the Athena table with glue crawler. So we have seen the creation of Athena table with glue crawler that is having certain steps. Okay, and at that moment what is happening, it is going to take the input based upon the data which is placed onto the path that you are mentioning, and automatically it is going to scan the data and define the columns and data type with respect to the flavor of the data. So that is the automated way. And over there, like if you just want to crawl the job, or you just want to have the creation of a table based upon a particular time, minute, or day, week, whenever you just want to have want to run that particular crawler, you just schedule it and it will keep on executing. So we will see how we will be able to schedule the crawler, how we'll be able to schedule the cron jobs and all. So we will see. But from the Athena perspective, what we have seen how to create the tables, and two options were there, like creating the table from S3 and creating the tables with glue crawler. Glue crawler, that is inferring the schema. Over here, the important stuff, that is, say we have created the table, that is fine, but once we are going to scan the data from that particular table, that is not going to provide any result, because the data which is placed in terms of partitions inside the S3 bucket, that is still not loaded inside the Athena table. So how to load the data inside the Athena table? We just need to run a command msck repair and table, and then you just need to mention the table name. So you just need to run this particular command, and it is going to load the partitions inside that particular table, and then you will be able to scan the data. Okay, and this is very important from the interview perspective. And like interview can ask the questions and in different ways. Like say I'm having certain third party applications which are running in background, and these are applications are creating certain partitions or folders or directories inside the landing onto the landing directory path, and you have created the tables onto top of that particular data, but you are not able to get the data with respect to the new partitions. With respect to the old partitions you are having the data, but for new partitions you are not having the data. You are not able to scan the data with respect to the new partitions which have been created. So at that moment you just need to like provide the solution that if like new partitions are there, those has been loaded, so you just need to run the msck repair command, and then new partitions will be loaded inside the table, and you will be able to have it. This particular command is working in Hive as well. Okay, inside the Hive as well, we are having partitioning related stuff, and if certain new partitions has been created or loaded onto a particular path, and those particular partitions are not available while executing the query. Okay, so at that moment as well, you just need to run the msck repair command, and you will be able to have those particular partition. So msck repair key is available in Hive as well, and it is working in the same way. So this was the stuff what we have seen with respect to Athena, and that was a service from the AWS side. So from AWS side, what we have seen EMR, EC2, S3. Certain stuff is pending from the S3, like we are having different types of S3 buckets. Okay, so but that is very simple. I will show you. So EMR, EC2, Athena, and S3. These are the services what we have covered so far, and what is pending, like glue, certain stuff from the glue has been covered. So glue, and after glue we will be going to discuss about Redshift. So those are the services which are pending from the AWS side. I will cover those particular services. Today we are going to discuss certain stuff from the Spark. Let me try to open a notepad. Okay. And what we are going to discuss, how to refer a column in PySpark. So how to refer a column, that we are going to discuss. Now, what we are going to do, we are going to create, open the PyCharm. Mhm. So we are going to open the PyCharm. It is not opening. Okay, it has been open now. Now, inside the PyCharm, I'm going to create a Python file, or notebook, whatever you want to say. New Python file. Let's say week 18. Let's say day 28. Okay, so what I'm going to do, I'm going to create the Spark session. So this is the boilerplate code. I'm just going to paste it as it is, and let me try to remove these particular things are not required. And day 28 and civic 18. And let me try to remove these particular properties as well. I'm not willing to have these particular properties. So Spark session.builder.app name is this one, get or create. That is perfectly fine. I will be able to create the Spark session. Now, what I'm going to do, I'm going to read a particular data. I'm going to read a particular data. Let me create a particular. Let me try to read a particular data. So for this, what I'm going to do, let me try to take this particular data only. So what we are having this particular data, and it is having certain records, say name, department, age, and date. Okay, and based upon this particular data, what I'm going to do, I'm going to create a particular Spark data frame, and Spark data frame dot show. So let me try to give a flavor of this particular data dot show dot show. Okay, that is perfectly fine. So it is taking some time indexing and all. It is that is going on. Once it is up, then we will try to execute it. I will give you a flavor. So what we are going to discuss over here, how to refer the columns. There are multiple ways in PySpark in order to refer a particular column. So that is the topic which was not covered in previous session. So I'm going to discuss about this, like how you will be able to refer the columns inside PySpark. So the execution is going on. That is in execution state. So we are able to get the details about the data frame. These are the records what we are having in this particular data frame. Now there are multiple methods what I have mentioned in order to refer a particular column. So let me try to mention the first method to refer a column. So first method to refer a column. So how you will be able to refer the column? So that is Spark data frame and dot select. I'm going to move with dot select and select what? So what I'm going to mention Spark data frame, and I can pass the column name. Say I just want to get the names of candidate, names and name and what I can have, say age. So I just want to have name and age information from this particular Spark data frame and age. So dot show. Okay. So let me try to print it over here as well. Print and first method to refer a perfectly fine. Now let me try to do the execution, and this is the first method in order to refer a column. Things are looking fine, and let me do the execution. So first method is data frame dot select, and you just need to provide the column names, how we were referring the columns in pandas or Python. So data frame and the column name in square brackets, data frame and column name in square bracket. So this is the first method in order to refer a column. Just have a look. Once it is executed, we will be able to extract two columns from the given data frame. And it has been executed. Just have a look. So we are able to select two columns from the given data frame and with the help of dot select. And the method what we have utilized over here, that is similar to the Python way. Okay, and we have used dot select API over here. So this is the first method. Now the second method. Second method. So second method to refer a column. And what I'm going to do over here, Spark data frame dot select, and I'm just going to mention the column names. I'm not using the data frame name over here. Say I just want to have the name and I just want to have the age information. Okay, that's it. So name and age information columns I will just want to have, and this is the way how I will be able to extract the information about the columns. So this is second method. Let me do the execution, and you will be able to have the two columns from the given data frame. Spark data frame, that is the data frame name what we are having. So initial data frame, what we are having, this is the first method, output with respect to the first method, and second method, and with respect to the outcome with respect to the second method. So we are able to get the outcome from first method and second method. Now what we are going to do, we are going to move with the third method in order to refer a column. So third method to refer a column. So over here, instead of select, I'm going to use select expression, expr. Okay, select expression, and I'm just going to mention, say, name and age dot show. That will be acting as a third method. Instead of initially we were using select, and we have defined the column names what we have seen in Python. So this is the simplest way. If someone is from the Python background, he or she will feel that this is the best method. Then second method, just remove the data frame name from there and mention the column names only, and you will be able to have that particular data frame or columns. You will be able to print those particular columns or get those particular columns. Third method, what we are doing over here, instead of select, we are using select expression, and just have a look. We will be able to get the information about name and age column from the Spark data frame. Okay, the execution is keep on going. Initial data frame, first method, second method, and this is with respect to the third method, and we are able to get the column names. What we are going to have, we are having the name and age column from the Spark data frame. This is the third method in order to refer a column. Now the fourth method in order to refer a column. Fourth method. So over here, the select expression, we are using select expression. So what we can do, instead of using expression over here, we can pass expr inside this expression expr. Okay, That's it. And we need to import this expression. So the quick fix, import this name. So let me do the import. So expression is moved inside the bracket. So select is utilized and we can pass expression over here, and then we will be able to get the data, the columns from this particular data frame. Just have a look. This is the fourth method. So second method, third method, third, what is the issue? Where? So it is showing var data frame expression dot show. Things are fine. Tool script. Just a minute. So we just need to import. Instead of this, we just need to import from SQL functions. So what we can do, I'm just importing all the functions and it will not throw any error at this moment. So wrong import was done and we have not seen like what was the imported expression is there from the SQL functions. Okay, so now you will not be getting any error. The error will be resolved at this moment. So the execution is going, keep on going. The initial data frame what we are having, the first method, second method, third method, fourth method, fourth method. Okay, this is the fourth method. The execution has been done, and what we are able to get, we are able to get the column names. So this is nothing. In another words, what you can say, this is a way in order to select a particular column or one or more column from a given data frame. How we are mentioning, we are just trying to move with the different, you can say, formats, and we are able to select the required column. Now the fifth method to refer a particular column. So fifth method and fifth method. So at this moment, what I'm going to do, I'm going to use a particular keyword that is call in order to refer the column. So instead of expr, I'm just moving with col, and column names a name, column name is, and I'm going to have these particular columns from Spark data frame. Just have a look and I will be able to get the column information from the given data frame. So the execution has been started. The execution has been started. Initial data frame, first method, second method, fourth method, and this is the fifth method. Based upon what I'm able to select the columns from a given data frame. That is perfectly fine. I'm able to get the information. So these are the 5 methods. Now there is one more method, and how I will be able to have that. So I will be able to have that particular method first creating a temp view onto top of this particular data frame. So create or Spark data frame dot create or replace temp view and say my table. So I'm going to create a temp view onto top of this particular data frame, my table, and this will be acting as a table. Now Spark dot SQL, and what I can mention, select say name, select name from age from my table. Okay, my table, that is perfectly fine. Dot show. Okay, so at this moment what I'm having, the sixth method in order to refer a particular column. Sixth method, direct name is from my table. Okay, let me do the execution. So initial data frame, first method, second, third, fourth, fifth, and sixth. So what we are able to get, we are able to get the same record. Okay, like we are referring or we are selecting a particular column, and we are able to get the data with respect to that particular column from the given data frame. Now it will depends on you which format you are going to refer, or which format you are going to, or which method you are going to opt in order to refer a particular column. And if we are talking about the performance, each and every operation or function what we have utilized over here, that is utilized in order to select a particular column. So from the performance perspective, there is no such difference. Each and every method is working fine, because we are not processing over here. We are just selecting the data from that particular column, what we are mentioning over here. So from the performance perspective, there is no such difference in these 6 methods. It will depends on you which format you are referring, or which you feel that is the easy one. You can opt that particular format, but with these particular format you can opt anyone, and you can refer or you can select a particular column. So these are the things with respect to how to refer a particular column. So let me try to paste this inside the notepad. So how to refer a particular column. So these are the 6 methods. How to refer the column. Just have a look onto this and ask if you are having any doubt. So these are the multiple ways in order to refer a particular column. Any confusion? This is the simplest one. like we are just having a particular data and we are going to refer uh, the columns based upon that particular data, and we are having multiple ways in order to refer that particular column. Okay, so the next thing what we are going to discuss, the data visualization. Data visualization. Before this, I just want to take the queries. If you are having any doubt, you can ask. All of you, Vandana, Rajbabu, Shivam, Rahul, Naresh, any confusion, anything that you want to ask?
No, no, it's okay. So, like, my question is like, if you select the column rotation,
Mhm.
so like, which one is more performant? It's like it will
That's what I mentioned,
in these
na.
all.
Like you are
Yes.
having six methods. We have gone through with six methods. So each one, if we are talking about performance, there is no such difference between these methods. Because like we are not processing something, we are just selecting the data, and processing will happen later on, and like post having the data, then we are going to process. So selection of data is not taking is not providing a difference. This is not making much difference. Like if you are selecting first method or sixth method, from the performance perspective these are same, almost similar, but uh, what we can say, there are certain operations what we can do, like we can perform the operations with expression, and we can perform the operations with selecting the column with col. Okay, so certain from those particular functions perspective, once we are going to apply certain functions, so we need to choose the correct one. Later on, like after the practicing these particular things again and again, you will be able to get an idea. Okay, so where to use with which method, but from the performance perspective it is not making any difference. There's no much difference between these six methods. Processing will happen later on after selecting the data, right?
Okay, got it.
Okay,
And
so
my table is also a calling function.
my table is a view. My
You
table is a
okay?
view what we have created onto top of this particular data frame. That is a view. Create or replace temp view.
Okay,
That
okay.
is a temporary view, right?
That's right.
Okay. So now we will move further with data visualization. And let me try to comment this particular stuff. Perfectly fine. The entire stuff has been commented. Okay. Now what we are going to do? Data visualization. For the data visualization, we are going to refer our flight data, flight data set. So let me try to read that particular data with standard data read API. So, so say this is the small flight data. Hmm. So we are having this particular data, and what we have done over here, we have utilized spark.read format CSV option header true option in for schema. This is the path and load, and just have a look about this particular data set, small flights DF. So this is the data frame what we are having, and we are just going to do the data visualization onto top of this particular data. Okay, we will be uh, going to learn certain stuff like how to convert this particular data frame into pandas data frame. So this is the data what we are having, and year, month, day. This is the data what we are having onto this particular path, a small flight data. That is perfectly fine. Now what we are going to do, say, let me try to do certain aggregation onto top of this particular data, and uh, what I can do from the aggregation perspective, say, just let me try to do, say, group by based upon what, say, based upon, say, origin. I just want to do the group by based upon the origin. Based upon origin, I just want to have, then I just want to do the aggregation of, then f dot count, and count of what, I just want to have the count of, mm, say, count of tail num, and I can give dot alias, uh, alias, say, total number of flights. Mm, Total number of flights of, let me do carrier. So what I want to see from this particular origin, this is the total carrier flight. Carrier is having these particular categories. I just want to have the origin having this particular. Let me try to total number of. Or I can do the group by based upon, say, carrier. Group by based upon carrier, then count of flight, count of flight. Let me try to visualize it. Count of flight, and then what I can have, f dot, say, average, and average of, say, arrival delay, dot alias, say, average delay, and I just need to import functions as f. From PySpark.sql, import functions. Yes, if, that is perfectly fine. Okay, let me try to visualize it on dot show. Let me try to visualize how it is looking like. So I just want to group by based upon carrier and count of tail num as to count of flight and f dot average, that is average delay with respect to this particular carrier type. The distribution will be with respect to the carrier type. So initial data frame, just have a look. So we are having these particular carrier information. For this particular carrier, what we are having, this is the count of flight and this is the average delay with respect to this particular count of flight. So this is a particular data frame what we are having. Carrier, count of flight, and let me try to count of flight. Count of flight, average delay. And with respect to this particular carrier, say UA, and we are having total flights this one, and this is having average delay 3.2 dot something. So we are having this particular data set. Okay, this is the data what we are having. Now what I can do, I can pass it to say small or carrier distribution. Carrier distribution distribution, and that is distribution. That is perfectly fine. Now carrier distribution. Now what we are doing over here, we are going to do the visualization based upon this particular data. Like we have done certain calculation, and now what we want to have the visualization onto top of this particular data. So inside the PySpark, how you will be able to do that particular data visualization. So inside PySpark, we are having certain libraries. Based upon that, what we can do, we can perform the data visualization, but that is not a good practice. Why that is not good practice? Because what we are going to visualize, that will be definitely a small data, and from that particular small data perspective, what we can utilize, we can convert that particular data into the pandas data frame. And Python is having a large support for different libraries. Okay, and we can do the data visualization based upon that. We can perform the data visualization based upon that. So for that, what we are going to do, we are going to convert this particular data frame into the pandas data frame, and then we will try to do the data visualization. That will be the normal flow what we are going to do. So this is the data frame what we are having, and what we can do, we can just convert this to pandas. Okay, to pandas, and what I can mention, say carrier pandas df. This is pandas data frame, and let me try to mention the type of print uh print type of what. So carrier pandas df and print type of carrier distribution data. Carrier distribution data. Carrier distribution data frame. This is the carrier distribution data frame, and just have a look. Okay, so this will be the pandas data frame. This is the way. Just you are mentioning the Spark data frame, and then you will be able to convert it to pandas data frame. Okay, so we are having Spark data frame, and we just have done the conversion of that Spark data frame into the pandas data frame. Just have a look over here. So we are having, this one is the pandas df, pandas core, data frame, and the second one, that is the PySpark SQL data frame. So first one is pandas data frame and second one is SQL data frame. Now what we want to do, we just want to do the data visualization onto top of this particular data. Let me try to print this. Say print carrier pandas distribution diagram. So it will show the data in pandas format, like you will be able to see indexing related stuff over there. Just have a look. So previously, like how we were able to visualize the pandas df data frame, so same you will be able to have over here. So just have a look. So carrier, the count of flight, average delay, and this is nothing but indexing related stuff. So we are having the data, and now on to top of this particular data, we just want to have the data visualization. We just want to perform the data visualization onto top of this particular data. So for the data visualization, friends, what we are going to do, we are going to utilize uh, the library from Python. So uh, say import matplotlib as ELT. So matplotlib. So we are going to install this particular package. It is not available in my machine. And import cbone as well. So we are going to do the installation of these particular libraries. Okay, so the installation is keep on going. And what we are going to learn, install failed package error. Matplotlib. So
PLT.
matplotlib. Matplotlib. Because of that, it is throwing error. So probably it has been installed. Indexing is happening. Skeleton is being updating. Python interpreter. So I think the error has been gone. So what we have done over here, so import matplotlib.pyplot as plt or import cbona. So these particular libraries are not there in my machine. So I have installed these particular libraries. Now what I'm going to do, what I have mentioned, based upon this particular, let me do the execution first, and we will be having the flavor of the data, and then we will proceed for the data visualization onto top of this. So what we are going to do, say plt dot bar, we are having bar plot, and onto what, onto carrier pandas df. So I just want to do the plotting of what, just want to do the plotting of, say, count of flight, uh, huh, count of flight with respect to, say, average delay, count of flight, and then carrier pandas, and I can have the second column as well, say average delay. Just want to plot this, and what I can do, plot dot, say, label, x label, and I can give, say, x label, that is a count of flight, and I can have y label as well, and say average delay, and plot dot, say, title, and say title, what I can give, say pandas carrier, say flight wise number of flights versus delay, average delay. Okay, so that is the title and plot dot show. Things are looking fine. Let me do the execution. So what we have done, we have converted the Spark data frame to Pandas data frame, and that is very simple. Just we have just mentioned like the Spark data frame dot to Pandas, that will be converted into the Pandas data frame, and we have seen the type of that. Then what we have done, we have imported matplotlib library, which is utilized in order to plot this particular data. Okay, so we are not able to. So this is something like uh, count of flight. So count of flight is very much high, and average delay. So this is with respect to flights and delay. So what we can do, count of flight versus average delay. This is average delay and count of flights. So our data is, you can say, having this much of distribution, and because of that, like, we are not able to have the correct picture, but we are able to see the data visualization inside PySpark. Okay, in the PySpark world, what we are having certain data. Okay, and with respect to data, we are able to have the data visualization. Let me try to uh, to
We are missing
check.
carrier names. No?
Hmm. We have used these
Like
particular
in
things.
this plot part.
You
But
want to have
as per
carrier,
the carrier,
carrier, okay. Carrier
yes,
delay with respect to carrier, okay.
yes.
Just let, okay. So we just need to close this, stop the execution. Is it stopped? It has been stopped now. So let me do the execution once again. Carrier wise delay. It will give number of flight is not carrier and average delay. Number of flight. Okay. So carrier wise delay. Right. So this particular, you can say US carrier is having more delay, less delay, and these particular carriers are having more delay, right? So we are able to
Yes,
say
yes.
have the pipe bar plot. We are able to have the bar plot. Okay. So this is with respect to the carrier versus delay. Okay. So this is with respect to bar plot from this particular library, matplotlib.pyplot as plt. From this particular library, we just have plotted the bar plot. So bar plot can be done with the Seaborn library. So we have imported Seaborn, and let me import Seaborn as SNS. SNS. This is uh, these are the like PLT, SNS. These are the industry-wise standard. So the persons are say utilizing this particular import in this particular format. Say bar plot, and over here what we just need to give say x equal to say the carrier, x equal to carrier. A little bit you can say format is changed over here, but the things will be the same. Y equal to and the average delay, average delay, and then data. We just need to mention the data what it will be. Data is carrier pandas df. Perfectly fine. And these particular things we can utilize. Plt dot x label, y label, and let me try to comment this one. Things are looking fine. Let me do the execution. So this is with respect to the Seaborn library. SNS bar plot we have utilized, and it is going to pick the details from here. Okay, probably we need to. Okay, so things are same, but the different library has been utilized, right? So we are able to have the bar plot as well from the Seaborn library. So what we have done, we have imported a data frame in the in the in the PySpark. We have imported a data, and we have created a data frame, PySpark data frame. Then we have done certain computation on the top of that particular data inside the PySpark only, and the result what we are having, that is the smaller one, and that particular result has been converted into the pandas data frame. Onto the pandas data frame, what we have done, we have plotting, we have done the plotting of bar plot. So bar plot we are able to to plot with respect to matplotlib library and with respect to the seaborn library. Now what we are going to do, we are going to do the visualization based upon certain other chart as well. Say I just want to have the pie chart on the top of this particular data. I just want to have the pie chart. So pie chart, what I can do, hmm, hmm. So say onto the number of flights. I just want to have the pie chart. Count of flights. Uh, Carrier, group by carrier, average delay that is in minus. Okay, let me try to do the pie chart. I have the pie chart. Pie chart is going to utilize the single column only. So we will try to do the visualization based upon these two columns again and again. So what I can do, plot dot pie, okay, pie chart, and what I can do, I can say first, like I just want to move with the average delay, plot average delay, and average delay. Then what I can do, with respect to the pie chart, so pie chart, so inside the pie chart, what I'm having label. Hmm, hmm. This is the column. Then pie chart, plot.py, average delay, then label. Just a minute. I just need to check for the syntax. Pie chart syntax in Python. Creating pie chart. So creating plot.figure pie data labels equal to cars. So cars is having this data and label equal to say. So what we are having for the labels, not label, labels, it will be labels. Okay, I have used label. It will be labels. So labels, and with respect to say labels, what I will be having, say carrier. Now let me give the carrier as a label. So we just need to use like label equal to uh, labels equal to carrier. Mhm. And it will be like this. So pandas df, this will be the label. And what we are having the third property as well over here. So third property percentage, that is auto pct. Mm, Auto pct percentage, that will be, say, percentage 1.1f percentage. Hmm. And dot axis. So I just want to have the equal axis. Dot title. Say pie chart. Let me give the pie chart and dot show. Let me try to do, and then I will explain it. Okay, so execution has been started. The execution has been started. Mm, so it is throwing certain error. So what is the issue? Dot pie chart auto carrier. No negative value. Okay, so inside this we are having a negative value. Because of that it is throwing error. That's what I was bothered about. So let me try to move with this particular thing. Count of flight. Count of flight. Hmm. Okay, so dot show. Why it is shown in this particular way? Pie chart. So let me comment all of these particular things and then do the execution once again. Hmm. Okay, so we are able to have the pie chart as well, right? So previously we were having certain negative values. So with respect to AS, the carrier AS, we are having the maximum contribution, that is 37.8. It is having max number of flights. Then we are having HA, that is having least number of flights. Okay, then B6, this is also having small number of flights, less number of flights. So in this particular way, we are able to have the pie chart as well of the data that we are having, right? Are you able to get on? Previously, it was taking certain reference from these particular plots as well, and it was uh, creating the issue. Now, what we have done, we have executed it separately, and then we are able to get it up. So over here, pandas plot.py, and then the data frame name, and the count of flight I want to have, and the label, based what label you just want to have. So it has plotted the label as well. So that is fine. So these two columns. Now the third stuff, auto PCT 1.1f, that is denoting, say, like digits after the percentage. So I have used 1.1f, so it will be going to visualize one percentage up to one decimal value. So one decimal value, if you want to have two decimal values, then you can change inside the percentage. Plot dot axis equals equal axis has been utilized. This is the title, and plot dot show, that is to display the plot to plot that particular chart. Now this is with respect to the pie chart. So we are able to get. So bar plot is done. Bar plot is done with this matplotlib dot pie plot library, and then the bar plot is done with the help of seaborn library as well. And then we have done the plotting of pie chart. You can based upon the data how you are going to visualize, you will be able to have that particular data. Now another thing that what we can do, we can do the histogram plot of that particular data. So with respect to the histogram plot, uh, that is quite possible over here. And how we can do that, we just plot.hist, and then what you just need to mention, I just need to check for the syntax. Syntax for hist plot in Python. So syntax, uh, hmm, hist equal to this bins this. So okay, so what I can do, I can do the histogram plot onto this carrier, this count of flights, and then what I can have bins information, say 10. I'm going to mention, and the label, and these particular things I just going to utilize. X label, say count of flight. Y label, what I can say, frequency. Count of flight, frequency, and the title, say histogram plot. dot sure. Let me comment this one. Perfect. Let me do the execution. Uh, so this will create issue. We will get certain errors. Okay, no. It is starting from here. So now we are going to plot histogram plot onto the top of this particular data. So this is with respect to histogram plot. Now over here, like what we are having bins. So bins is going to, the bin is going to provide uh, bin. So optional parameter contain integer or sequence of string. So what this particular bin is going to do, say the records. So say you are having over here, what you are able to see, we are having 10 records. And we have used 10 bins. So 10 records. So all of the records are plotted independently. So if I'm going to use bin equal to 5, you just need to see. So it is going to merge these 10 records inside the 5 numbers. Over here we are having 10 boxes. So if we are going to reduce the bins, so it is going to merge the outcome in inside the 5, you can say, blocks. Just have a look. So bin equal to 5. So those 10, you can say, 10 records which you want to plot, those will be merged and it will provide you uh, the shrink view. Just have a look. You will be able to see the difference. Once you visualize it, you will be able to get the difference. Okay. So previously, now we are not able to see. Just have a look. It has been merged together. So the previous one was a little bit different one. Now it has been merged together. So although like the range we are able to get, but these particular things are came together. Let me try to snip it, and then we will be able to match it with the previous one. Okay, so bin 5, this is with respect to bin 5. Let me try to mention bin 1, and then you will be able to see. It will be merged in single block. Bin 1. Now we are moving with bin 1. This is bin 1. Each and everything came closer, and this is with respect to bin 5. Bin 5 and bin 1. And now what I want to give, say, bin 20. Bin 20. So the good number is with respect to your records. Say if you are having 10 records, so try to give bin equal to 10. So you will be having 10 different records, and you will be able to visualize with this particular histogram. If you are going to like increase or decrease with respect to the number, then visualization will not be so much good. You will not be able to differentiate properly. So over here we are having bin 20, and the separation is there, and this is with respect to, say, bin 5. Bin 5, and now what you are able to see with respect to bin 20. Right, are you able to get the difference with respect to bin parameter what we are having?
Yes, sir. But actually the bin is showing, sir. Actually, what purpose?
Bin is going to merge these particular records. Like these particular records will come together, come closer. It is going to merge. So this is the same, you can say, distribution what you are able to see. So over here 1 2 3 4 5. So these particular records come closer, and now you are having this particular outcome. Okay, just have a look. So these records, these up to 1500. So all of these particular records come closer, and you are having this particular view, right? But in actual, say if you are having certain number that is around say 11 1200, from 1200 up to 1200 we are having say three frequency. What I just want to show over here, just have a look onto this particular data. So it is going to provide the frequency based upon these particular number. Say 1051, 1082, 11886. These are the numbers, these are like closer to each other. So with respect to these particular number, what we are having, if we are keeping bin, you can say 20. So this is the bar which is providing the information about these particular records. Even this one as well. So 1500 up to 1500. So 1 3, so up to this one, say 1051, almost over here we are having three records with respect to say 02, less than 500, less than almost say 200, almost 200. So with respect to 200, what we are having, 186, that is 173 2, 181 3, then 2144. So we are having four records, the frequency is 4 over here. And then 200 to 600, almost 600. 200 to 600, 1, we are having say 214, 1 we are having this one, then this one. Okay, 2, almost 2 are there. So 2, this is giving 1. So in this particular way, probably like for 482 we are having this one, and for 382 we are having one number over here. So we are able to get this particular information, right? So what histogram plot is giving, it is providing the frequency or the distribution of a particular column, how this particular column will look like. So this particular column is having, say you are having certain records, like you are having the marks of students. Say students are getting 40 marks, some students are getting 30 marks, some students are getting 90 marks. So you just want to uh, like count how many students are getting 80, or say you are having certain range. So how many students are getting 0 to say 200. So based upon that, like we are getting the count. Say four students are there, 5 students are there. So we are plotting the numbers with respect to its frequency, that is giving by histogram. So same you are able to see over here, numbers with respect to its frequency. So then like after 1500, say 16, almost 1600, we are having one number only. So just have a look, 3784, this is the only number after 1500. So that's why it has been plotted over here, right? So this is the way in order to visualize histogram. Fine, Naresh.
Yes, yes, got it.
Yes, sir. Fine, fine. But
Okay,
actually, sir,
when there are others.
sir, just a minute. Sorry to interrupt.
Hmm. The main
Bins
thing,
means it's showing the spacing, just
yes, yes,
showing
it
just
is. Yeah, it is going
okay,
to merge. Say these are the 10 records. If you are going to bins, you can say one bin, one record, two bin, two record. So if you are having 10 record, you can have 10 bins. So inside 10 bins,
okay,
you are going to have 10 record. If you are going to say mark the 10 records in one bin, then you will be getting entire blue. You will not be able to
okay. Yeah,
visualize.
it's showing
If you are
merge
using
all of them.
if you are using 5 bins, okay, 5 bins, then also you are not able to visualize in a good way.
Yes,
Over
yes,
here you
yes.
will be able to see, say up to this, what we are having, say up to 500, what we are having, we are having six records, up to 800, what 800 or 900, what you will be have, you will have six records, you just need, you can calculate it over here, say 800, so 1 2 3 4 5 6, 6, so how many records are there, 6, so we are having six records up to 800, right? Then from 800 to 1500, or almost 1600, 800 to 1600, so 800 to 1600, what we are able to see, so 1 2 3 and 4, four records are there, right? So four records are there for 800 to 1600, then from this 3000 to 31,000 to 39, say, 39, what we are having, we are having single record only, so what we are able to see over here, so we are having one record only, that is there after 3000, right?
Right, sir, right. Got it.
Okay, so this is with respect to histogram plot, now what we are going to do, histogram plot, that is fine, so another plot what we are having, that is box plot, hmm box plot, so let me try to comment this and say plt dot box plot, box plot, and what we can do, we just need to mention the the column name, say onto the count of flight, I just want to have box plot, and I just want to provide the information, say X label, Y label, and histogram. So just I will move with this particular labels. You can change these particular labels, but I just want to show you how the box plot will be there. Plot dot show, how you will be able to see the box plot onto top of this particular data, and this is very interesting as well. Box plot. Just have a look. So count onto count of flight, I'm just willing to have box plot, and box plot is going to provide me the outlier, we will be getting the outlier related information with the help of box plot, so in this particular data, what we are able to have, we are having the box plot over here, and this particular value, this is nothing but outlier in this particular data. So this is an outlier what we are having box plotted over here. So after this, what we are having the outlier. Let me try to show this box plot onto the another column, that is average delay. So let me try to map it onto the average delay as well. And let me try to show you something. Okay, so with respect to this one, like what we are having, like the data, the all the records are within the range. But how you will be able to do the analysis of this particular box plot? So over here, like the entire box plot is divided into four quartile. Say first quartile, that is 25th percentage, second quartile next 25th percentage, third quartile the next 25%, and the fourth quartile. So over here what we are having, uh, the values from 0 to 25, that is lower whiskers, lower whiskers. And from values from the 75th percentile to 100 percentile, that is the upper whiskers. So over here what we are going to do the analysis, we will be able to calculate the interquartile range. Okay, interquartile, that is nothing but IQR. So once you will be going through with once you will be working on to certain machine learning algorithms, then this particular IQR calculation will be there. And what you just need, with the help of box plot, you will be able to check the outlier. You can think in this particular way. Say in the previous plot, the values will be beyond our upper whiskers limit. So the values which are beyond the upper whiskers limit or from the lower whiskers limit, that is nothing but outlier. Those particular values are nothing but outlier. You can take it in this particular way, like you are getting the data, like traffic report, throughput report or traffic report onto daily basis. Then you have plotted the box plot onto top of that particular data, say because of certain events or certain, say today like we are having cricket match in Ahmedabad. So the sites, the telecom towers which are deployed over there, definitely those will be having the huge traffic, heavy rise in the traffic will be there. So in order to, like, you are doing the analysis of that particular data, and now you are plotting that particular data with the help of box plot. At that moment you just need to question to the domain specialist, like why we are having outliers in this particular day. Do we need to move this particular data, or do we need to avoid this particular data? Because these are certain events, that can cause the change inside the algorithm, that can change, that can provide that can have a lot of impact onto the accuracy of your algorithm that you are building onto top of that particular data. Like you are, say, working onto the traffic forecasting, or like throughput forecasting, like this will be the throughput what I will be getting with this particular deployment. But because of those particular outliers, the accuracy will be less of your model. Then what you can do, either you can consider those particular outliers or remove those particular outliers. At that particular call will be taken from the domain specialist or domain expert. So these particular things are utilized in order to do the analysis of outliers what we are having in the world of data science. So these are, say, certain plots what we can have, and we will be able to plot uh, or visualize the data with the help of the Python library, just converting the data which we are having into pandas data frame, and then we will be able to plot this. So that's it with respect to visualization. If you are having any doubt, you can ask. Any doubt, any confusion with respect to the stuff that we have covered?
No, I
No,
Mhm.
sir.
think
Perfectly fine. Okay, let me try to paste it over there. Data visualization in. Mhm. Okay, so data visualization. This is with respect to the data visualization. So we are reading the data, then we are plotting over here. We are creating a pandas data frame onto top of PySpark data frame. Then we have plotted the bar plot, pie chart, histogram, and box plot. So we are able to do the visualization. So that's it for this particular session. Let me stop
Sir,
recording.
one query, just one query.
Hmm, 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 hmm.
Sir, it's necessary to create data frame into Panda data frame to plot.